You can start. You can
Oh,
start.
sorry. Hi, everyone. My name's Cameron. I'm going to be presenting Drivetrain Basics to you. Just to give you a little bit of background on who I am, I've been involved in FIRST for about 10 years now. I've been a member, mentor, and now coach of Circuit Runners Robotics, Team 1002 FTC, 11347 FTC, and 1002 FRC. I've been to World several times, so I've seen a bit of everything. A good robot. I volunteered at several events, so I've seen a bit of every robot. So this is just some of the things that I've also modified the presentation because after some of y'all have seen the game already. So this is going into pure strategy and basics of what drivetrains you guys can be looking at for rookie teams and or veteran teams. So starting off, we got tank drive. So tank drive is one of the simplest forms of drivetrain possible. It can be done with very, very limited resources. Most of the time, you're talking about at least 6 wheels in order to make a tank drive work well. Reason being is you want to have wheels that are going to be able to let you turn on a center point. With 6 wheels in either configuration, so on the right, that blue picture, that one has 3 on the one side has 3 wheels, 2 of which on the outer sides are omni wheels. Omni wheels have wheels that run perpendicular to the regular wheels' range of motion, which means that it will help you turn on a pivot very, very easily. Omni wheels are available in like every form and fashion, are allowed in every form and fashion through FTC. So that's what that will do. So it will let you turn on a center point much easier. 6-wheel tank is similar. So you have 6 traction wheels. Usually one of the things that you will have to do with, if you go with this 6-wheel tank drive route of all the wheels being the same, one of your wheels, ideally your center one, will have to be dropped down just a little bit, 1/16 to 1/8 of an inch. What that allows it to do is you're actually, when you're rotating, you're going to be rocking back and forth between your front 2 wheels and your back 2 wheels. If y'all have ever been to Home Depot and you've seen one of those big lumber carts, ones that have all the handles and they wobble back and forth, like they're almost like a seesaw at sometimes. That's exactly the same idea. It'll let you turn a lot easier and go around corners and just turn on a pivot because of that, versus if all 6 wheels on the ground, you're fighting yourself at every step of the way. So that's one of the things where a lot of the kits that you'll see talk about tank drive as well as Mecanum, which we'll get into later in this video. It's extremely simple. You could use 2 motors on it. You could use 6 motors. You could use all 8 motors for all that some teams matter. It's an option that you guys can use, and it's a good way for a lot of teams to get started because it's so simple. Now going on to a little more complex drivetrains. These are called holonomics. Holonomic drivetrains just mean that they can move in all directions at almost any time. And there's usually, competitively, there are 2 big forms of this in FTC. So on the right, you'll see an image of what looks like as omni wheels, each on a corner of the robot. What that allows is so I don't know if y'all can see my mouse, but so when these wheels are rotating here and this back wheel is rotating in the same direction, you'll be traveling in this direction. Same thing here. You want to travel this direction, you can travel like that. You can travel at 45-degree angles very, very efficiently. Now, if you want to go straight, you drive these wheels, all 4 wheels in the way you want to go, and you'll go in that direction. Now, later, if you get some fancy programming and do some extra work, you guys can work on moving at 30-degree angles, 31-degree angles, and essentially have a very wide range of motion very, very easily. It just requires a little bit more complexity. Now, for FTC in particular, the most seen across the board, every single team at World Championships that makes it to finals and or wins finals and goes on to Festival of Champions and everything uses Mecanum. Mecanum has been around for several years now. There's several resources on how to make Mecanums work well. GoBuilda has a strafer kit that's been sold out for a few months now that is all purely just the Mecanums. It's just a Mecanum drive base that you can buy off the shelf. Andy Mark does a similar thing. It's their tile runner, which both have a Mecanum and a tank drive option. Both of those are very viable in this setting, especially if you're starting off. Mecanum can be a little bit harder, but if your team thinks they'll enjoy the challenge, it's with the amount of resources, the amount of help that you guys can get from other teams, from online. I think there's at least 15 different places where you can find the code for the Mecanum robots and modify it for your needs. Now, Mecanums, being this right here, have omni wheels on the wheel itself, but these are at 45-degree angles. So what this allows is when you rotate one set inwards, so if you rotate these inwards and these outwards, it'll completely strafe sideways. It'll go completely sideways to where the regular range of motion is like this. When you turn your motors like that, it'll go side to side. And also by altering your power of your motors, you can go in all directions very, very easily while still keeping the robot frame square. You won't have to turn. Both of these you can turn on a center point, which in almost any game is very, very valuable to turn on a center point, because it means that you're not going to be possibly swinging something outside the field as easily, because swinging something outside the field is almost always major penalties unless the game allows it. Now, a lot of these, you'll see different ways of driving them. We're going to talk about how you can drive your drivetrains differently now. So, Chen, any questions so far?
No, there have not been any questions. But yep, 36 participants. So congratulations.
Oh, yeah. Hey. Yeah. Okay, so continuing on, we're going to go to how can your drivetrain be built? So, direct drive. So at the bottom of your bottom here, we have an example of both drivetrain or direct drive and belt. Direct drive means that you take that output of your motor and slap it straight onto a wheel. That is usually it's the simplest way of doing things, yes, but it also can hurt you in the long run. Let's say your robot gets dropped. You're not only dropping your robot on the your wheels, you're now dropping them straight onto the motors. If your motors die, you're going to have to buy new motors, and that's just some wasted investment that you don't really want to do. Especially if you have younger students, sometimes accidents happen, and we play with giant robot RC cars, so some damage is going to happen at some point to some of them.
So Cameron, we actually have a question by individual. He asks, can't you control the angle on the Omni by editing the speed of each motor?
Yes, you can. So I think I was trying to mention that earlier. I'm going to give you just so y'all know, I'm a mechanical nerd. I'm not a programming person. I know enough to where I can say, I don't think that's quite right, but I'm mainly a mechanical guy. So yes, you can do the same thing like with Mechams. You can change the angle and angle of your direction via the speed of your motors. Same thing as Mecanum. Just going based off what I've seen competitively at all these competitions, the best teams in the world go towards Mecanums because they're a lot smaller as well. There's a lot of different things that you can do, but it's up to personal preference. I think every team does their own thing for a reason, so that's always an option. Going back down here, So direct drive is an option. I would highly, highly recommend you look at almost any other option though. Now a gear train, just a second, let me make sure I'm muting. There you go. But a gear train is when you either have a motor to a gearbox that you either create separately or a gear ratio to your wheel. So at the top here, you'll see you have a gear here that's driving this other gear, which is your wheel. This has a lot of advantages. You can change how fast your wheels are going based off that, and also allows your motors to be in different places. You can have your motor halfway across the robot and still achieve the same idea. Gears, on the other hand, do have their issues as well. Everything in robotics is a pros and cons, has their pros and cons. So with this, with gears in particular, you want to make sure that they're meshing properly. So they have to be close enough together in order for them to mesh. Otherwise, they can skip. You may not be giving the full force behind your drivetrain, which can cause other issues of you're not getting enough speed. You're not able to achieve what you're looking to achieve. Gear trains, I've had teams put an entire gear train across the entire robot. Now, it's an option, and I've seen plenty of teams do it. It is not, in my opinion, the best available option because every single time you add a layer of gears, there's a little bit of play. So there's a little bit of play here, there's a little bit of play here. So when you try to rotate one gear, it may take you a quarter turn in order to even get the wheel all the way at the other end of your robot to even start moving, which can be, not the best idea when you have fairly small motors and they're trying to turn all this ahead of time. Now, if you are trying to power something like a motor at the back end of your robot and want to power the motor or power the wheels at the front of your robot, that's when you can go to chain or belt. Both achieve the same idea, just with different ways. Chain is using sprockets, and it's the same idea. Belts is the same way, except you're using pulleys. Either option is good. You have an example of chain drive right here, where you can see the sprockets. The chain has been removed on this, but you can see the sprocket here and the sprocket here, and it drives this one assembly on this mecanum drive. So what this will allow is just, it keeps everything streamlined. So you see here that the sprocket and the motor are all in this small little section, while this one is you have the wheel here, the gears here, and your motor's now sticking up. So you're taking up more space in the same, while you could be taking up this much space. Smaller footprint essentially can allow this. Sorry. My brain's moving faster than I can talk. But with gears, you can't always, you have this layer, you have a thicker layer of metal to deal with versus sprockets, which are usually thinner. Belts are thicker than chain most of the time, but they do achieve the same thing. They're both very, very viable in competitive FTC, and at almost any level of robotics, you will see either one of these being used. Chain is a good example. It's used on bikes a lot. Belts are used a lot on 3D printers. Different aspects, different opinions, but they both achieve the same end goal. So you can see here on this one as well that you got the motor that goes straight to this pulley that drives this pulley all the way at the end of the wheel. And all that extra, quote unquote, play that you'd get in a gear train is now eliminated both with a sprocket design and with chain or with a belt, because that's where you're going to gain a lot of advantages with simple mechanical movements instead of trying to turn a gear to turn another gear to turn another gear to turn another gear to eventually move a wheel, which those all achieve. They all achieve the same thing. That's the majority of what I want to talk about. A lot of this stuff you can find online of other resources. So you can go on to Rev Robotics. They show how you can build a mini bot, which is very, very simple. You can look up on GrabCAD. GrabCAD is a great resource for FTC and FRC teams to look and see what kinds of drivetrains are available. Same thing with GoBuilda. GoBuilda sells the Strafer kit. The Strafer kit is currently, I believe, sold out for the next several months, but it's a great tool that you can buy and immediately drop in, so your team doesn't have to worry about build, quote unquote, designing and building. Now you can still design and build your own, modify, whatever you want. It's just up to personal preference, in my opinion. Any other questions so far, Jin?
No, there have not been any questions related to the PowerPoint.
Okay. Moving on, there's actually not that much, because usually for these classes we would have robots so we can actually demonstrate what all they do. So right now would be our question and answers time. So if you have any questions, please send them in the Q&A chat. Then we'll have a discussion. And if you have any other questions just about FTC in general or anything, we can try to get to that. But if you have any immediate questions relating to drivetrain, robot mechanics, anything like that in particular, we'll try to answer those first, I believe. So I believe we have a decent number of participants now. So whatever y'all have on your mind, please send it in. Anything yet?
Nothing as of now. Would you like to talk a little bit about because the game was recently released? Would you like to talk a little bit about the game and how you would approach it?
So, okay, that's going to be a whole discussion then. Okay, so going into game strategy a little bit. So when I teach teams, when I mentor teams, I have 3 philosophies in terms of robot design and how to approach almost any problem. Rule number 1 is imitate the best and invent the rest. If you want to learn something well, you look at who are the best teams. Who are the best teams in your state, in your league, in the world. Imitate them, because imitation is one of the best forms of flattery. So, I mean, it's just one of those things where you want to put your own spin on it, but look and see what's been done before, which leads straight into number 2. It's been done before. First, robotics in general has been around for so long that we joke that they've run out of game ideas. This game has similar elements to previous games over the past couple of years, which I'll talk to you about. We'll say about in a second. Third rule is the rule of KISS. Keep it simple, students. There's a lot worse ways of saying that, but students is the most gracious professional way of saying that at this time. So going into what I'm noticing with the game, FTC in general has not had a lot of shooting games, especially with or launching games, as we could probably call it, is in its history has not really had that many. We had Velocity Vortex, and I believe that was about it. Now, if you look at what objects you're shooting this year, they're kind of like a frisbee. In 2013, FRC had a frisbee game that was very similar. When I say very similar, they had at least 2 different goals, a high and a low goal. They were only able to carry 3 frisbees, which are 3 rings. And they had to shoot it from a certain back line in order to gain the points. What that means is you look at the same principles. So if you look and see, oh, they used XYZ mechanism in order to achieve XYZ goal. Okay, what can we use our resources, what are parts that we have, or parts that we need to make, either 3D print, CNC, laser cut, whatever the heck kind of manufacturing methods you have, even cardboard. Cardboard is highly underrated in terms of effectiveness sometimes. So it's just something where you got to play around with it and look and see what other teams have done in the past. This game is also just very, very similar to, I'm trying to remember the autonomous wise. Relic Recovery is the thing that comes to mind, but I don't think it's quite correct. But Relic Recovery, which is an FTC game from 2 years ago, no, 3 years ago now. Gotta remember, it's a new season, it's a new year. With that, we are gonna sorry. So the autonomous period during that, you had options that would switch out every time. So you had 3 different options that you go. So it'd either be something here, something there, something in a third position. With that, you gotta be able to say, okay, if X, if this thing is in position 1, what is our end goal with that autonomous period? Because something that is also very underestimated, especially in Georgia and a lot of other places in the world right now, is the value of autonomous. If you just look at the power shots alone are 15 points apiece. There's 3 of them, you can score them twice. You score those 15 during autonomous, well, that's 45 points. That's just doing that alone. You can get 5 points here and 20 points there, but those 3 points right there can swing a game. And for a majority of us being in remote events, it's going to be one of those things where you have to be able to play and say, okay, we need to go into this being the best team, being the best one robot team. Now, when you guys do get to traditional events, unless you're Etowah, where you're the only traditional event place right now, as far as I know. Maybe I'm incorrect on that, but either way, you have, oh shoot, you have what? Okay, now I can't remember what I was saying. So I lost track of myself. Shoot, crap. I guess we'll go on to the next topic that I had, which was look at those foam rings in particular. If any of y'all, some of y'all may have grown up in the 90s. I don't know if you're coaches or majority of y'all are probably students. Nerf, it's a blaster brand, so you shoot foam all the time. Those rings are made of foam. Has Nerf, an industry that makes their money off of flinging foam, done anything like this in the past? This was a common practice done a few years ago when FRC started to shoot foam balls. They did a similar thing of, oh, what does a fast pitch machine look like? What does a Nerf blaster do when it's shooting a ball? That kind of thing. It's the same kind of idea of it's been done before. Look at what other things have done in your industry and make it work for what resources that you have available, which I think is going to give you all a very distinct advantage over some other teams. Nothing yet, I'm assuming, on questions? Or
There actually is a question.
okay, there's a question. Let's hear it.
How about tracks or treads instead of wheels?
So that is an option. Personal opinion. I'm going to give you my personal opinion and my personal experience with tracks. A couple years ago, FRC parts created Rhino tracks. Rhino tracks are great. They're expensive. How many teams use them? 3. How many of them were very successful with them? Very, very, very few. Mainly because they're higher maintenance than wheels. Treads are more likely to break. So and especially in FTC, your tread options are fairly limited. One tread that I've seen in FTC used is Vex chain. So there's Vex chain that you can use like little tread pieces to attach onto it. And it's made out of plastic. Even higher or better quality chains, or not chains, but better quality tread belts tend to fail. They pop off. And once those pop off, you're kind of left in the dust. You have no way to drive your robot easily. Or if you only lose it on one side, well, now you just have a spinning robot in a circle. Whenever you want to design a drivetrain, you want something that's going to be quick, reliable, and easy to maintain. Because you got to think about this. You're running these robots for hours. If you're doing proper driver practice and everything, you should be running these robots for over 100 hours by the end of the year. So, I mean, so you just got to think about, it's an option. I'm not going to discount it. I haven't seen very many teams use it successfully. Uh, it's an option, and I've seen some teams for their outreach robots do that, where they will put treads on it and make it go off-roading. But that's a very niche scenario versus something where if you're looking at a competitive robot scene like you guys should be trying to look at, it's going to be a lot tougher to use treads. Hope that answers the question, but
Yeah. Another question. For a newcomer, can you explain the wheels in the two lower robot bases in your photo?
so these two, I'm assuming. So
I think so.
because yeah, there's
Can you explain both, or
I'll,
like all
I'll
three, just
explain
in
all
case?
of them. So all of these wheels here. So these two, this green one, these gray one, and this one red one for some reason, and these orange ones are all called mecanums. Mecanum drivetrains, what they do is they have their wheels on a 45-degree angle compared to where like a regular tire will just rotate regularly. Imagine your tire having several smaller tires at 45 degrees all the way around the wheel. What that means is here I have a really good diagram that actually explains just a second. Let me find it. I had it right here. So this is what mecanums will do. So mecanums in particular, so they always have the 45 degrees like you see here. So with that, when you rotate the wheels in different ways, they'll do different things. So in this case, if you rotate two sets of wheels outwards and two sets of wheels inwards, your robot's going to go sideways. If you just drive this back right wheel and this front left wheel, you're going to go at a 45-degree angle sideways. You want to try and turn on this corner on this wheel. You can drive these two forward, and then you will turn on that wheel. You want to turn around in just a circle. Again, drive one side one way, the other side the other way. You want to turn around this back side of your robot. You drive your front two wheels in opposite directions. For mecanums in particular versus 45-degree omnis, they just allow for a lot more range of motion in that sense, where you can get really, really fancy with them and pivot on one wheel corners or pivot on this backside, while a 45-degree omni can't quite achieve that same goal. Now, these other wheels over here, so you see these omnis right here. These same omni wheels are also what are used on this drivetrain right here. So you have them right here at the front and the back, allowing it to. So those rollers or those wheels have rollers on a 40 or not 45, but a 90 degrees, so they're perpendicular, meaning that I can roll these. I can roll these wheels completely this way, and it won't have any kind of resistance. So these wheels will just roll, which allows for just greater range of motion. Mecanums just have a lot more flexibility in terms of what they can actually do. 45-degree omnis is a great starting base for holonomic drivetrains. If nothing else, it's a good summer project. They're fun little drivetrains to do because if you do them, you can also make them very, very simple for certain applications.
So another question, but before we talk about that question, if you guys would like, I can post all of this stuff on the JoJo First website. So if Cameron will send me the diagrams, I will post them on the first website, and so you guys can go back and review them. And if you plan on using those, or you need a reference, you could just go on the JoJo First website. It's the same session, and I can place all the images there. But yeah, another question is, what should you consider when picking between direct drive, gear train, chain, and belt mechanisms?
Personally, I will say it does depend on the year. For certain cases, my personal preference will always be belt, just because I believe that belt is a very, very easy way to tension things. Now, let's say you have something that, so belts, you can order custom belts for different size applications. Those can get fairly expensive. Chain, on the other hand, you get a giant roll and you just attach it back to itself. You can add small links in order to make it a little larger or a little smaller. That's how you can tension chain. I've had personal bad experiences with chain over the years, but chain in general is a good option. So direct drive, I just always prefer to stay away from it just because let me put it this way. I helped start a rookie team. They went with a direct drive robot. They accidentally dropped it down a flight of stairs. Those were the only two motors they had, and when those dropped on the wheels, they lost. They couldn't afford new wheels after that, or new motors. It was a really, really rough season for them. But yes, so personal opinion, avoid direct drive at all costs. If you can find something that will help disperse the load of a fall or of the weight of the robot onto other components and make your base more solid, that'll help you a lot more. So yeah.
So another question that came on is tips for using chain/belt with mechanism, or are gears just the preferred way to go?
So even in the pictures I've shown you, you can see that some teams have used gears, some teams have used sprockets, some teams have used belts. It's really up to personal preference at that point. I believe I'm trying to remember what it's called now. The Strafer kit that's sold by GoBuilda uses uses chain, if I remember correctly, chain and or gears. I don't know of any current ready to purchase drivetrains on the market for FTC that use belt. I've seen them use chain and gears. It's up to personal preference. For example, here, these sprockets are the same size, meaning that whatever this motor is spinning, there's no change in speed there's no gear ratio there. So it's just a 1-to-1 drivetrain. Same thing with this image. This belt is the same as, or this pulley is the same as this size pulley over here, meaning that the motor speed versus the circumference is what your speed will be. While this one in particular, you see where they have a really, really big gear here, and most likely either a bigger gear here because either way, let's say there's a gear ratio here. There's a bigger gear or a smaller gear and a bigger gear here. That allows you to do different things. Some teams can afford these gearboxes that will say, oh, every 4 rotations on my motor will give me 1 rotation on the output, meaning that I have more torque. Some teams can't, so they have to use other methods, just as an example. It all depends on personal preference and application. I've seen gear-driven arms. I've seen belt-driven arms as well, just mechanically. They both achieve the same thing, but again, personal preference / use case. Mechanisms, though, in particular, if you can stick with chain, because mechanism typically tries to move fast, you want to have something that will really grab and bite and make those mechanisms move. So either gears or chain would probably be one of your 2 better options in that particular case. Belts is another option, but again, belts can cost a little more money.
So the other question, which is more of a statement, came from the same person who asked, how about track or threads
Okay.
instead of wheels? He said one of the Tetrix kit robots is tread-based.
So I believe, yes, you are correct. I think one of them is. I'm I will say, if you want to, do a little bit of research on it. If you guys want to go that path, I will highly encourage you to try it. I'm not going to stop. There's no reason for y'all not to. I just don't believe it's the best possible option. But again, that's my opinion. I have the right to be wrong. So, with that though, I will also encourage you to go back over the past 5 or 6 years of just FTC and or FRC. Look at World Championships. Look at the teams and their robots. You can use the Blue Alliance. The Orange Alliance is a good resource. Even just Google Images in YouTube. You can find videos of those matches and look and see what those drivetrains were. See how many, because honestly, I don't know. I don't know every single team that used a tank tread system in the world. I can tell you from what I've seen personally, that's where I'm giving my advice from. But again, this is all up to you guys. That's your decision to make. I believe if we're going to get into build systems with Tetrix versus Rev versus GoBuilda, that's another discussion, I believe. But yes, they do sell one. It's the whole joke of just because you could doesn't mean you should. That's what I'm going to say about that. I'm fairly opinionated when it comes to robots, and so that's that.
Another question that an individual asks is, what are the discs made out of?
Say again?
What are the discs made out of?
The discs. Oh, for the game, I'm assuming?
I believe so.
The game this year, they're made out of foam. I do not know the specific material. That's probably going to be found in Game Manual Part under that particular thing. But it's foam. It's fairly lightweight. I mean, it's maybe a few like. Not going to even try to guesstimate weight on that because it's not. I didn't have a lot of time with them, but they're foam. They're fairly flexible. They do compress a little bit, but that's about it.
What are the pros and cons of tank drive?
Pros of chain drive. Chain in general is a lot. What?
Wait, I said tank drive.
Oh, tank. Oh,
not chain.
Sorry, I heard chain. My bad. So tank drive. The advantages of tank drive is in a competitive scene where you're actually trying to, let's say, I'm trying to think of a good year. Velocity Vortex comes to mind for FTC. So 2016 game for FTC, you had, what was it? All 4 robots going around the field, almost hitting each other, trying to push each other out of the way. The advantage of tank drive at that point was tank drive, you can't be pushed side to side, unlike Mechanum and Omni. So what would happen is if you're tank drive and you're pushing up against the side of a Mechanum bot, that Mechanum bot is going to move. It doesn't matter how much power they put into it, they're going to move. Because that's what they have, is they have those rollers, they're going to be moving. In this game in particular, you're not going to the other side of the field for almost any reason. The field, even though it doesn't have a physical wall in the middle, could, meaning that it's very unlikely for a team to cross over to your other side and try to get in your way. And if they do, that's going to be most likely a penalty on them or it's unsportsmanlike conduct, essentially. Ungracious professionalism. I don't think that's the correct term for that, but I digress. Tank drive has its advantages. I've seen it used in 2016, 2017 year, in particular, Velocity Vortex, so to help push other robots out of the way for other teams to achieve their goal. Granted, that year, you didn't really have a true side of the field. Everyone was going around the entire field doing different things. So the main advantage is you have pushing power. You have a lot more power behind it to push someone out of the way. Mechanum, you have the agility. So, yeah. What
What
else do
about
we have?
what about some cons?
Oh, cons.
Probably mobility. Is that
Mobility. I mean, that's the main one. Really, is in terms of maintenance, both mechanical and pretty much all drivetrains in general should be designed fairly easy to be worked on very easily. Now, with tank drive, yes, mobility is an issue where you can't go side to side. So if you let's say wanted your right side of your robots, let's say this this is your robot, this is the front side of your robot. You want the right side of your robot to be able to pick up a ring from the side and like a ring going this direction. You can't, because you can't go straight sideways on a tank drive. You can't go at an easy diagonal. You have to turn and do that, which means that you could limit yourself in terms of what your maximum capabilities could be. Unlike a Mecanum where, let's say, oh, I want my intake on this side of the robot and this front side of the robot. You could have intakes on all four sides of your robot for different balls, or just throwing out examples, balls, the rings, anything like that. You could have every side of your robot be a way to grab stuff versus a tank where you really only have two options. You have your front and your back.
Okay. So here's another question. Do you have any tips for mounting motors to the robot?
Uh, it depends on your build system, but my main thing whenever you're mounting a motor is you want it to be mounted to a very structural part of your robot. You don't want a very thin piece of plastic. Let's say you have a piece of polycarbonate and you mount a motor to that, especially like a high powered motor, either to move an arm or to, I don't know, spin up a wheel to launch a hockey stick out of the way. I don't know. You don't really want to do that because that plastic can't hold that kind of force for very long. It can crack, it can shatter a lot easier. You want something that's going to be structurally stable. So metal ideally is a lot better. If you look at almost all of these designs that you're seeing here, this is the motor right here. It's attached via bolts to this side panel. These motors are attached to this gearbox frame, which is also attached to the rest of the robot. Uh, these are attached via brackets. They're motor mounts that are attached, giant pieces of metal that are attached to other giant pieces of metal that make up your frame. Same thing here. They're mounted face-wise onto pieces of metal. Same thing here, a clamp. Same thing here, a clamp. Ideally, I would say face mounting, so where you can actually like screw it into the metal, is going to be a lot better than a clamp, because these clamps can rotate. If they're not tightened down properly, they can rotate, meaning your motor can rotate as well. So if you're trying to spin up your motor, you're not going to be driving your wheel, you're going to be twisting the motor's wires around itself, and where either you get a braided wire, which can look really cool, or a severed wire, which means you have a dead motor. So that's that.
Another person asked, what build system do you like the best?
Ooh, belt system.
Build system. What build system do you
Oh,
like the best?
build. Oh, sorry.
No, it's fine.
I swear I'm either going deaf or dumb or something, or a little bit of both. But build system. If I had to pick, I've used Tetrix. I've used Vex, like the Vex EDR, the metal and green plastic. I've used Vex Pro, which is solid box tubing. I've used AndyMark Rev Extrusion. I've used 8020. I've used GoBuilda. For FTC in particular, if you're trying to get something that's going to be simple, effective, and worth your money, GoBuilda will be your best bet. GoBuilda and or Rev Robotics. Rev Robotics sells a very, very good kit. Though a majority of those components are plastic, they allow you to modify your parts ahead of time. So let's say you have slots, so you can always add more things into that slot. You can screw pieces of metal together without seeing a bolt. You can do a whole ton of other stuff. Go built. So like you see these rails right here, that's rev extrusion. It's this long rail looking stuff that you can put bolts and nuts in and it will hold it all together. This up here is Tetrix, which, don't get me wrong, it's a decent build system, but for your money, you can get Rev Robotics build system, which is usually a little bit cheaper, or you can get Go Build a little bit more expensive, but for your money is going to be your best value. Go Build a sells great motors. They sell high quality connectors. They sell high quality wheels, tension systems, everything. Vex Pro is another option. It's usually used by more FRC teams, but if you're looking for something that's going to be a little bit more custom, so like you're going to be cutting into a piece of metal to make that your plate, instead of just buying, I have this C channel that has a whole ton of holes in it. That's another option, is Vex Pro. But for your money that you can get a kit out of, Rev Robotics and or Go Builda. A lot of these kits don't have cross compatibility easily, so Go Builda actually does have that though. That's why they have so many holes, is so you can slot Tetrix, you can slot your rev extrusion in there. That's why I think Go Builda is probably the better system and also is worth that little extra price tag. Also, just to give you some perspective, there is a reason why the Go Builda strafer kit, so this is almost exactly a strafer kit to a certain extent. You get a mecanum drive base and a few bits of metal to make a frame, is sold out, and it was sold out halfway through summer. And I think it's on back order now for the next couple months. Versus the Rev kits, I mean Tetrix, I don't think Tetrix has ever actually sold out of almost anything. Tetrix has good individual parts, but in their build system in general is not only seen as outdated, but is outdated in other ways as well. The gears are aluminum, so they can shred quite easily. Their aluminum itself is very, very weak. Like, I can bend it physically. Like, I can bend their C channel with very minimal effort. I'm not exactly the biggest, strongest guy in the world, but the fact that I've seen other people who are not as strong as me still bend that piece of metal is concerning, because of what happens if another robot hits it. What happens if your robot drops? Just things like that. So Go Builda, Rev Robotics. Those are your two best ones for your money.
Another question is, which drive system works best hand in hand with mechanism wheels?
Drive system.
Drive system works best hand in hand with mechanism wheels.
So I'm assuming by drive system you mean like how your joysticks are. With that, there's a thing called arcade. Arcade drive is similar to, like, if you've ever played a first-person shooter game or any kind of video game like that, where your left stick is. Now I'm trying to remember this. I haven't played video games in a while. I'm a little bit of an old guy now, so left stick is your turn, so you can turn left and you turn right. While right stick is your move in every direction. So you move forward, the entire robot goes forward. You move sideways, you strafe sideways. You move right, you move right. That whole thing. And in order to turn, you use your left and right. That's like your point of view, and your right stick is your movement path. Hope that answers your question.
Any other questions, everyone? That was the last of the questions that I've seen. So if anybody else has any other questions, feel free to comment them in Q&A.
If you have any questions about FTC at this point, I mean, ideally build system more related, but if you have any questions about the game so far, or keep in mind, I've not fully read the game manual. I'm not a referee. I'm not like at a field right now where I can measure the game elements. I'm just saying, if you have any more game specific questions, game strategy, anything like that, at this point, ask me anything, almost anything. Keep racist professionalism, please. Keep a GP.
Make Woody proud.
Actually, speaking of, I still have Woody as my background.
Oh, wow.
I mean, man impacted my life quite a lot. So
Yeah, we still have around 10 minutes left. So if anyone else has questions, feel free to ask. If not, we can end the session early, and I'll go inform my superiors.
I mean,
I'll give it another 5 minutes, and I'll
give it a few more minutes.
Yeah.
I'm trying to see, like, do I have a whole ton of robot parts here that I can show off or anything crazy?
Oh, yeah. There is 2 more questions.
Okay.
Is there email we can use to ask you more questions as like a reference email?
Yes, you can. It'll. Okay.
I will post it on the website.
Okay.
well.
So, I believe
Just email me.
Cameron.Huggins@circuitrunners.com.
Okay.
That's the best way to get into contact with me. And if I can't answer your questions, I can find someone who knows a lot more than I do to answer your question as well.
Circuitrunners.com?
At circuitrunners.com, yes.
Spell that right?
CAMERONHUGGINS at circuitrunners.com.
Runners.
Yes, runners. Yes, there's always an S.
There you go. And then could you repeat that again, but slowly?
Oh, sorry. CAMERON.HUGGINS at circuitrunners.com. Not going to try and spell out circuit runners because my brain is already struggling trying to figure out how to spell my own name right now.
Time management. How would you proceed with design / build / etc.?
So in terms of your design and build, when is state championships? I believe that almost every team wants to make it to state championships and or to world championships. So you got to figure out when your league championships is. That's usually going to be December or January. So starting from September, you have the rest of September, October, November, and at least probably halfway through December. So that gives you at least 3.5 months. So let's say that's about at least 15 weeks to figure out what do you want to do? What do you want to figure out? In my opinion, any kind of drivetrain decision should be made very early on and not gone back on. I've had teams say, oh, we're going to use tank drive. And then halfway through the season, they said, oh, well, we want to do Mecanum now. So they stopped working on their tank drive bot altogether, and they just focused on their Mecanum bot, which they never got running until after the season ended. They didn't even make it to state that year, which I felt so bad about. But as a mentor, I can only do so much. I'm not going to force students to do something they don't want to do.
2 questions that kind of go hand in hand.
Okay.
Also keep in mind we have around 5 minutes and a little 6 minutes left.
Okay.
What advice would you give first-time tech teams with only FLL experience, and what are some resources you can offer to the new rookie teams?
2 new rookie teams. Just mainly if you're looking at FLL, a lot of the same principles apply, especially competitive FLL. Read the game manual, analyze the game, understand what's the main things that you want to focus on. If you want to go for high scoring points, what is the most important priority right now for those points? And then also when you make a decision, don't go back on it. Unless your robot completely fails, like let's say, you build an arm, that 3-axis arm just has never worked. As soon as it stops working, you need to set a deadline saying, okay, no, we got to work on something new. In terms of resources, YouTube is going to be one of your best friends. YouTube, GitHub is a great place for code, but YouTube, you can look up almost anything on YouTube and you will find it. You have world championship teams there showing off what they did for presentations at World. You have teams about their robot, what they did with their design. Heck, for rookie teams as well. there's things called robot in 3 days or robot in 24 hours. It takes the FTC game, and as soon as the FTC game is revealed, that group has 24 hours to build a competitive robot. And that's what they mostly do, is they take elements and figure out, okay, how do we make this work really quickly? So I'd recommend keep a mind out for those videos. Watch videos. And as soon as teams start posting about what their scores are, watch their videos, look and see what they're doing, because you may be on the same path as them, and you can say, hey, well, they did something similar to us, so let's see what they did that was better. How do we become better than the best team in the world? What was the other question?
Those were the two questions that they kind of go hand in hand, so I thought I'd ask them together. Is that all, everyone, or are there we have time for one or two more quick questions?
Yeah. I can't answer the question of life, okay? That's not my job. But I can answer some robot questions. Anything you got? Hit me with your best shot.
I think we have a couple
Hit me
more
with your best shot.
Some people typing. Okay, I think that would be all for everyone. I will stop recording now, and we can proceed with the next sessions.
Okay. Thank you all for coming. I mean, like, y'all were great. You asked some good questions. If you have any more questions for me in particular or anything, please either rewatch the video or email me. June's going to be posting the email on the Georgia First website. I don't know why I was struggling with that, but it's been a day. Kickoff day. Everyone should be excited. Have fun. Please be gracious professionalism, especially in this time. Like, that is my one word or two words. Be a gracious professionalism. Be a gracious professional. I can't. Okay, we're done. I'm done.